Hello everyone, welcome to this video on prerequisite skills. Today we're going to learn or relearn the basic skill sets that you may require for computer science, and these topics include arithmetic operations, remainders and modulus, powers and exponents, factors in the nth root, rounding, and we'll end it off with order of operation. Let's talk about the arithmetic operators. So some terminology for you to start off. Sum is a result of an addition operation, whereas a difference is a result of a subtraction operation. And then we are going to talk about some binary operators. Binary operators are mathematical or computational operator that takes two operand. Right here we have 42 minus 6. For the subtraction operator, these are our operands. And then this is our subtraction operator. So for a binary operator, we need two operands. Moving on to addition and subtraction. I know this might seem a little trivial, but you do need a full understanding of how addition and subtraction work. Addition and subtraction is a mathematical operators that simplifies like terms. Both operators manipulate their terms by moving them along a number line, which you see below. The symbol for addition and subtraction is the plus sign and the little dash with a minus sign, respectively. And then addition and subtraction is deal with like terms. All variables with same letters, symbols, and with the same exponents are considered like terms, and all constant terms are like terms, such as numbers, constant, pi, or the Euler's constant. For example, for variables, x squared and 6x squared. Those are like terms because the symbol and the letter are the same and the exponents are the same. And we can simplify these by adding an add sign. And we can evaluate that to, or simplify that to 7x squared. So let's do some addition. Right here for question A, we have 41 plus 39. We always add the ones first. And to look at this wholly, we are collecting like terms. We have two constant terms and we want to collect them. And how we're going to collect them? Well, we have 41. It's going to move to the right, 39 spaces. So this would just give us 1 plus 9 is 10. The 1 carries over. 4 plus 3 is 7. So we get 80 returned. Here we're doing a subtraction operation with the operands 17 and 12. So this would just be moving the positive number 17 12 spaces to the left. That would give us 5. 7 minus 2, 5. 10 minus 10, 0. Gives us 5 returned. Moving on, and we have 2 plus negative 47, or the quantity of negative 47. In this situation, what I would like you to do is imagine a 1. And whenever we have a constant in front of a bracket, we're going to multiply to get rid of the bracket. So we have 2. 1 times negative 47 is 1 negative 47. So we're going to take 2 to the left 47 spaces. That gives us negative 45. So 2 plus negative 47 will give us negative 45. Moving along, now we have a negative 22 subtracted by a quantity of negative 11. We have 1 here, and we're going to multiply negative 1 by negative 11, so we can rewrite this expression as negative 22. Negative 1 times negative 11 gives us positive 11. So we're going to be now negative 22 add 11, going right to the right 11 spaces. That gives us negative 11 as our final answer. Make sure whenever you're getting rid of brackets, make sure we multiply to get rid of brackets or parentheses. Let's move on to multiplication. Multiplication is the repeated addition of a number. And when we multiply, we get a product, which is the result of a multiplication operation. And we can have factors. Factors are the operands or numbers that multiplies to create a product. And for multiplication, there is a rule or a property that states multiplication is commutative. which means that changing the order of the operands will still result in the same product. Therefore, if we do A multiplied B, then we can get B multiplied A, or those two expressions will be equal to each other. There are various symbols for multiplication. We have the cross symbol when two brackets are touching each other. That is also multiplication. There are also as dot, or in computer science, you'll definitely see an asterisk. So let's do a multiplication. In this case, we're multiplying 3 by 4, where we are adding 3 4 times, because it is a repeated addition. Therefore, 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, that gives us 12. And let's look at the commutative property, where we're doing 4 times 3. Well, we're going to do the same thing. We're going to repeat the addition of 4 3 times. 4 plus 4 plus 4, where 4 plus 4 is 8, and 8 plus 4 is 12. Therefore, we can say that 3 times 4 equals to 4 times 3 because of our commutative property of multiplication. And down below, I've provided you with a multiplication table of 12. And what I really do recommend is that without even using a calculator, that you will be able to produce these numbers when asked to multiply certain numbers. Let's move on to division. Division is the act of splitting into equal parts. It is considered the inverse operation of a multiplication. So if A times B is equal to C, then A is equal to C divided by B. And a dividend is divided by a divisor. So in this case right here, this C is the dividend. And B is a divisor. And when we do a division operation, quotient is the result of a division operation. A little concept, division of 0, it is considered undefined as the value is essentially infinity. Division is also the evaluation of a fraction. So if we talk about fractions, they're essentially a division as well. And when a dividend is not evenly divisible by a divisor, we get something called a remainder. Or the quotient will be a member of real values. That means we might have decimal points. So we'll be dealing with a lot of divisions and a lot of numbers that have a remainder, or we'll be dealing with decimals in computer science. So it is very important that we do understand how long division works. So let's look at these two division operators. We're going to divide 132 by 12, and we're going to also divide 10 by 3. So here we go. So we have the number 132, and we're going to divide it by 12. Essentially, we want to look at how many 12s can I fit into 132. Well, even beyond looking at that, I have 12 and a 13 right over here. That fits, right? So I can take one of those, and that gives me 12. 12 times 1 is 12. Therefore, I can get, then we do a subtraction here. 13 minus 12 gives us 1. We drag the 2 down. Hey, 12, 12. 1 times 12 is 12. Then we can subtract them in 0. Therefore, this is equal to 11. Let's see how the next question works. We're going to do 3 divided by 10. Well, 3 can't go into 1. This doesn't work, so we have to look at how many 3's can we put into 10. Well, we know that 3 times 3 gives us 9. That will give us another 1. At this point, we can put a point and make that a 10, which give us 3, 3, 3 infinity, or 3 over 10 is 3 with the remainder of 1, because we have remainder. And let's clean that up a bit. So there are two possible answers here, where one will be a decimal root and one will be a remainder root. 10, 3, that gives us 9. The points, and 3, 3 continuous. Or we can do this as 3 divided by 10 10 divided by 3, where we can take 3, that will give us 9, and we have this 1 left over, which gives us a remainder of 1. So we talked about our arithmetic operators. Now we're going to go into remainders and modulus. So a remainder is a leftover when a dividend is not evenly divisible by a divisor. And a modulus is the operation. It is a division operator that helps us to just evaluate for the remainder. So if you go back to these top examples, 132 divided by 12 will give us a 0 remainder. Whereas 10 divided by 3 will give us a remainder of 1. And modulus operator is usually denoted either by the percent symbol or the letters MOD. So to calculate for the modulus, we just simply do a division calculation like before. And this will give us 11. And our modulus is equal to 0. Here, we're going to do 10 divided by 3, and 3 goes into 10 3 times. We're going to subtract those values. We get 1. Therefore, we get a remainder of 1. Therefore, the 10 modulus of 3 is equal to 1. And that's how we get our remainders. Let's move on to powers and exponent. What is a power? A power is a repeated multiplication of the base with exponent number of time. B to the exponent of n is powers only occur when n is greater than 0. And if we look at the number 2 to the exponent of 31, that is read 2 to the exponent of 31. I just want to reiterate that this entire concept is a power, where the number 31 is our exponent, and the number 2 is considered our base. Therefore, that's why we read this power as 2 to the exponent 31. Some exponent properties. If we have a power b to the exponent n, if n is equal to 0 and b is not 0, then it evaluates to 1. If n is less than 0, as in it's a negative, it will create a reciprocal. Therefore, b to the negative exponent negative n will give us 1 over bn, which kind of looks like 1 over b to the exponent n. Looking at b to the exponent n, if n is greater than 0 and n is less than 1, as in it's a fraction or a decimal, it's usually a root finder. For example, b to the exponent of a half is a square root, and b to the exponent of 1/3 is a cubic root. So we can say that b to the exponent of 1/2 is the same thing as the square root of b. And if we have a b of root cube, that is the cube root of b. And here are some exponent laws that you should know by now. This was covered in grade 9. And here's the various laws, and you should take time, maybe pause the video to even practice and refamiliarize yourself with these exponent laws and the examples that they create. Let's go into factors and roots. So factors are the operands or numbers that multiply to create a product. Finding factors. Well, we can say that if we have a number x, and when we divide it by b, we get a remainder of 0. Then we can perfectly say that b is a factor of x, because it's divisible. B is divisible by x, or x is divisible by b. Therefore, b is a factor because we can multiply a certain number to get the number x. And the act of prime factorization is finding all the prime factors that multiply to a number. For example, if we have the number 16, then the prime factors are 2. For example, we can say that 2 to the exponent of 4. And 12, it would be 2 and 2 and 3. Prime numbers. Prime numbers are a number that is a number that is evenly divided only by itself or 1. So numbers like 2, 3, 5, and 17 and whatnot. There's a whole set of them, and prime numbers are actually really fun to deal with in computer science, which we will see later. Then let's talk about the nth root. It is the one of the inverse operation of an exponentiation, and we can look at it this way. The nth root of x is the same thing as x to the exponent of 1 over n. Therefore, the cube root of x cubed is just x3 over 3. Therefore, it will just evaluate to x. The nth root from an x will give us y, where y multiplied n times will equate to the value x. Rounding. When trying to round to a number place, we round up if and only if the right adjacent number is greater than 5. For example, 1.6 is 2.0. 10.1, that number is not greater than 5, so we'll round down to 10. Now, in computer science, there's the concept of floor and ceiling. No matter the right adjacent number, the number is rounded down if we apply a floor operator to a number. So if we have 1.6, we're going to floor it, then it will become 1.0. 10.1, we're going to floor it, then it'll be a 10. Whereas ceiling is the opposite. No, we go up no matter the right adjacent number. Therefore, the number 1.6 will be rounded up to 2.0, and 10.1 will also be rounded to 11. And let's finish it off with order of operation. Please remember that we follow order of operation whenever we do mathematics, where we evaluate everything in the parentheses first, then the exponent, where division multiplication will be in the order of left to right. Then we'll look at addition, subtraction, left to right as well. So that's all we learned today, where we were learning or relearning the basic skill sets that we require for computer science and looked at arithmetic operation, remainders and modulus, powers and exponents, factors and roots, rounding, and order of operation. Thank you for watching and stay classy.